So we've got question 9 about Darren. And in class, we determined that if Darren drank a latte with 205 milligrams of caffeine each hour, this equation represents the amount of caffeine remaining in Darren's bloodstream as time passes. So every hour, if he's losing zero point zero 0.08 or 8%, then he's keeping 92%. So when we look at question 2, it says it wants us to write a formula to model the number of hours since Darren drank his latte based on the amount of caffeine. So we're taking the inverse. Now we want to know hours based on caffeine instead of caffeine based on hours. So the first thing I want to do is bring in X and Y. So get rid of the C, get rid of the H, and Y equals this. Now, when we're taking the inverse, the big step is X and Y trade places. So now X equals 205 times 0.92 to the Y. And I need to solve for Y, but Y is in an exponent. So I need to get my exponential base alone. So that 205's got to go. So we divide both sides by 205. So X over 205 equals 0.92 to the Y. So now I need that 0.92 to come back down and go away because I want to bring Y to the baseline. So I'm going to take the log base 0.92. So I take the log base 0.92. I've got my equation with Y alone. I've achieved my goal. So now what I want to do is just bring in the notation based on hours and caffeine. So we H of C gives us the log base 0.92 of C over 205. And to finally finish this question off, they say, how long will it take for the caffeine in Darren's system to drop below 50 milligrams? So 50 milligrams is the amount of caffeine. Now that I have this equation, I can just put 50 in for my C. When I do that, I get 50 over 205. When I put that in my calculator, I actually get the H of 50 is 16.922. And that's kind of crazy when you think about it. That caffeine is still going to be in Darren's system 17, almost 17 hours later. And that's number 9.